Hello, everyone. Welcome to our next lesson. Thank you for being able to watch this on the video and taking the time. Like I said before, you don't have to take notes, but it would be in your best interest to do so. Some of the examples are from the packet that you're going to be getting from your people anyway. So pause the button, pause the video now, and try these warm up. All right, hopefully you gave it a try. This was a review from Algebra 1. So let's start with the first one. So if you remember, the opposite of square rooting something is to square it. So we're going to square on both sides. And I get, the nice thing about on the thing on the left is when I square a square root, it cancels out. If you look at it through like rational expressions wise, you end up with x minus 2 as a quantity to raise to the 2 over 2, which cancel each other out. So I'm left with just x minus 2. And on the right hand side, I have 49. And so from there, I'm going to add 2 to both sides. And so what you want to do from here is always check to make sure it works. So if I plugged it back in, 51 minus 2 is 49. Square root, we get 7. So we're good. On the right-hand side, though, when I subtract 9, I get negative 7. The problem with this is that I can't take the square root of something and get a negative. So therefore, we don't have a solution here. Okay, so hopefully you didn't just go ahead and go through the process. You're paying attention to what numbers you are getting. And for this last one here, my advice would be to change the 64 so that it was a number with exponents. So in this case, 64 is the same thing as saying 2 to the 6th power. The reason I want to do that is because of that root 5. What I'm going to do with all of the exponents is divide through by 5. Now, as you're dividing by 5, whatever you would get comes on the outside and remainders stay in. So for example, when you do 6 divided by 5, you get 1 with a remainder of 1. So what that means is that we have a 2 to the 1st power on the outside because we divided, we got 1, and that remainder stays inside. Same thing with the x. When I do 12 divided by 5, I get 2 with the remainder of 2. Now if I divided 4 by 5, I can't get a whole number out of that, so that would be just inside, wouldn't come out. And then 18 divided by 5 would be 3 with a remainder of 3 because 18 minus 15 is 3. So the first thing we want to do is looking at the packet from last block. We are going to do those last couple of examples. So turn the page, you'll see a problem that looks like this. They're very blurry, so hopefully you can use this to help you out. So I'm going to go through how I would do these problems. It is not the only way to do the problems. Um, the first two that we're going to go through might be pretty quick, pretty simple. The last two that we're going to do have fractional exponents. And so we need to remember this new rule here is that we cannot have fractional exponents in the denominator. So in the end, no negatives, no fractional exponents in the denominator. So for this one here, the process I would take would first to be combine everything inside. So m and m would give me m squared, n cubed and n gives me n to the 4th, and I have p to the negative 1. Then from here, I would distribute through with the exponent of 3. So I have m to the 6th, n to the 12th, and p to the negative 3. Anything that's negative needs to become positive, so I'm going to change p to the negative 3 so it's in the denominator. Now, if I'm talking too fast, I'm sorry. You could always pause and rewind if you need to hear that explanation again. All right, moving on to the second one here. As you saw, we skipped the very first two, 1 and 2. So once again, I'm going to combine everything together first. You don't have to. In one of the other examples, I didn't, just to kind of give you that idea. But when I multiply here, 2 times 2 gives me 4. You could also write it as 2 squared if you wanted to. When you combine your x's, you get negative 3. Y squared has nothing to combine with, and my z's combine to give 6. Then I'm going to distribute through with that negative exponent. So I have 4 to the negative 3rd because we have a technically exponent of 1. X to the 9th, because negative 3 times negative 3 is a positive 9. Then I get negative 6 and negative 18. And so from there, I'm noticing that all three of these that I've highlighted in red are negative. They need to become positive. Now, as I change the 4 down to the denominator, I'm also going to evaluate. The 4 to the 3rd power is 64. I am expecting you to evaluate. So anytime you have like 4 squared or 5 to the 3rd power, actually go through and multiply them out. So up top, I end up with the x to the 9th because it wasn't negative. And on the bottom, 64, y to the 6th, z to the 18th. All right, so these are the ones that might look intimidating, but that does not make them any different than the last two problems we just did. So you're just going to take it one step at a time, combine your things together if you want to, subtract the top and bottom, but you always need to make sure that we don't end with a fraction exponent in the denominator. So first thing that stands out to me here are the zeros. You see how this whole quantity here is raised to the 0 power and this p is to the 0 power? So what we want to do is kind of get rid of that. So it's going to equal 1, so it's like it's not even there. So what I'm left with is m to the 4/3 on top, and on the bottom I have p m to the 2/3 and n to the 5/3. I didn't do anything there. So then, just like before, we had something like m to the 4th over m to the 2nd. We would eliminate those, not eliminate those, but simplify those. We're going to do the same thing. So before we would subtract them, we're just doing the same thing. It's just with some exponents. So 4/3 minus 2/3 gives me a positive 2/3. That tells me it's going to remain in the numerator. The p and the n to the 5/3 stay in the denominator. So here's the thing. This n to the 5/3 can't remain. We need it so that it has a whole number exponent. It's the same idea as having a square root in the denominator. If it says 5/3, that means we have a cubed root of n to the 5th power. And we can't keep it that way. So what we need is to get this 5/3 to become a number such that we can actually divide 3. So my goal is to get this 5/3 into a 6/3. And in order to do that, I just need to increase it by one more third. So what I'm going to do is multiply your top and bottom by n to the 1/3. And again, the whole purpose of that is because I'm going to do 5/3 plus 1/3, because remember we add exponents here, and that gives me my 6/3. And because 6 divided by 3 is equal to 2. So what you see here is we do have an n in the numerator, and we do have an n in the denominator, but you don't want to go through the process of doing subtraction, and then you would end up with a negative, and it would come down to the denominator. You would just end up going in a circle over and over again. So the big idea here is it's okay to have a variable in the top and the bottom that's the same variable. This one at the bottom cannot have a fractional exponent. This one at the top should be simplified as far as you can. Okay? All right, let's take a look at our next one. So this one, again, I get that it looks intimidating, but it's not as bad as you think. So in this one, I did not combine r and r to the negative 1/3 and r. So what I went through with is multiplied those through with the numerator on the top, and I didn't simplify any of the fractions. Please make sure you do that in the future, though, like when you're all done with the final answers. So when I distribute through with the negative 3/2, negative 1/3 times negative 3/2 is 3/6. If you write 1/2, it's the same thing. Negative 3/2 to this r just gives me negative 3/2. For both p and q, since we're timesing by negative 1, this becomes positive 3/2. Denominator, nothing happens. So then from here, what I want to do is take care of my like terms. So what you want to do here is combine these two at the top. So essentially we're doing 3/6 or 1/2 minus 3/2 first. So really up at the top I have r to the negative 1. And when that moves down to the bottom and joins the 7/4, I end up with r to the 11/4. For my p's, 3/2 minus 1 is 1/2. 3/2 minus negative 5/4 is 11/4. But once again, I have this down here. My goal is to get this 11 to be a number that's divisible by 4. The next number would be 12. So to get this to be 12/4, I need to increase it by 1/4. And so what I'm going to do is multiply top and bottom by r to the 1/4. What happens in the denominator is I have 12 over 4, which is 3. Now, you are perfectly okay with skipping this step right here if you don't want to write that down. If you just want to go here, okay, I'm going to times it by r to the 1/4 straight to here. That is okay, just so you know. So this would be our final answer. Again, it's okay that we have an r in the numerator and the denominator. So what I want you to do right now, if you are watching this video in class, is pause this and work through the front of page 2. There are 12 problems, just like the ones we just went through. Try to work on these. I'm going to check these next block on Wednesday. Give yourself about 15 minutes to work on them and then keep going. If you're watching the video before class, then just go ahead and keep moving. The second half of this video here, and would be the lesson if we were in class, is about solving radical equations. Most of this is probably going to be a review for you, so we should get through this pretty quickly. Our steps here are to first isolate your radical, then take the square or cube root, or undo the square or cube root, whatever the index is, and simplify. And then if the equation still contains a radical, repeat those steps. If not, continue solving and always check for extraneous solutions. It's going to get you. All right, so these next few examples are found on the packet that should be given to you. So if you're working on this in class, you can just fill out those examples right in there. So this is our first one here. Remember, our first goal is always to isolate the radical. So right now I have that -2 here. I'm going to move it over through addition, and I get -3. The difference here now is I have a cubed root instead of something like a square root, but that just means I need to cube both sides. So again, the nice thing is on the left, when I cube a cubed root, I'm just going to get the 2x minus 3. Negative 3 to the third power is negative 27. And just to kind of address that, it is okay to get a negative answer when I have odd exponents, just so you remember. All right, so then from there, I'm going to add 3 to both sides to get negative 24 and divide to get negative 12. Don't forget to check extraneous solutions. So what you'll do is plug it back in. So for example, 2 times negative 2 is negative 20, 12, 2 times negative 12 is negative 24, minus 3 is negative 27, cube root, negative 3, minus 2 is negative 5. So this works. Again, it's okay to have that negative in there because it's a cube root. All right, so let's move on. At any point in time, if you want to pause and come back or just work through the problems on your own, memory always welcome that. So again, we want to isolate the variable here. So I'm going to move my 2x to the right-hand side. That gives me negative 2x plus 8. So when I go to square this to undo that square root there, the only thing is we're going to have to FOIL the right-hand side. So square root of x plus 1 squared is just x plus 1. But on the right, when we FOIL it out, we end up with 4x squared minus 32x plus 64. So keep in mind, we end up with a quadratic here. So that means we have to get this to set equal to 0, and then we're going to factor. So I move everything over to the right-hand side, and I get 4x squared minus 33x plus 63. At this point, you have to go through and factor. I'm going to do all of that for you in one step. So just know that this factors into 4x minus 21 times x minus 3, and I am expecting you to know that. And that means our answers are 21 over 4 and x equals 3. But if we plug 21 over 4 back in, we don't get 8. So this is not one of our answers. And you can always verify that with your calculator if you'd like to double check my math. Okay, so we just get 21 over 4. Okay, and the only answer that works here is going to be 3. All right, on to our next one here. Since we have 2 radicals, I'm going to choose one to move over. I'm moving that 3x plus 4 over because it has a minus sign. Doesn't mean you have to. However, when I go to square both sides on this side, you're going to write it twice and then FOIL. So negative 2 times negative 2 is 4. That's what you get when you multiply firsts. Outside insides, that's going to give us a negative 4 times the square root of 3x plus 4. Because an outside will give us negative 2 times the square root of 3x plus 4, and that happens twice. And the nice thing about the square root of 3x plus 4 times itself, it's just going to give us 3x plus 4. So at this point here, I still have a radical, so I'm going to isolate it. So I'm going to combine my like terms. So this 4 from here and this 4 from here is going to combine to give me 8. I'm going to then move this 3x plus 8 over to the left-hand side. When I subtract 3x and subtract 8, I get negative x minus 12. I still have this negative 4, though, so I have to take care of it. Since it's negative 4 times the square root of 3x plus 4, I'm going to divide. What I end up with is 1/4 x plus 3. So I got to get that square root out, so I'm going to square both sides. Excuse me. It's not as bad as you might think just because there's a fraction. So I get 1/16 x squared plus 6/4 x. If you write 3 halves, same thing. And then plus 9 when I FOIL that out. On the right-hand side, I got 3x plus 4. Now, since I have an equal sign, I am going to get rid of the fractions as I like to do. You do not have to get rid of the fractions. But again, I'm only allowed to do that because it's an equal sign. No equal sign, no getting rid of fractions. You're going to have to suck it up with those. So what I end up with is x squared plus 24x plus 144 when I distribute through equals 48x plus 64. Now this process from here on out is really what I would do. This is not the only way. You could have kept this as all over 4 and done this a whole different way. So just keep that in mind that the way that I'm showing you is not the only right way to do things. All right, let's isolate or get everything to one side and get it set equal to 0 because again we have a quadratic. And I end up with x squared minus 24x plus 80. Hopefully this one's a little bit more obvious. This is 20 times 4, which is 24. So x minus 20 and x minus 4. We have the two answers of x equals 20 and x equals 4. Nice thing is, both of them will work out. You can always go back and check my math. How about you try this one? All right, let's check your work, see how you did. So when you move the x over and FOIL, and then we're going to set it equal to 0 and factor, we get x minus 3 times x minus 8. So our two answers here are 3 and 8. However, 3 does not work if you plugged it back in. You will not get negative 5. Okay, so if you're feeling a little tired right now, here's a nice little joke. Did you hear about the circus fire? It was intense. Or my all-time favorite joke, what's Beethoven's favorite fruit? Banana. Take a breather before moving on to that classwork. Just know you don't have to do the whole thing. That is the test 1 through 10 and 31.